Good day, grade 11 learners. I'm Mr. Benedicto de Yoliales and welcome to another Math Amazing episode here in NCR Math TV. Several TV hosts are saying that coronavirus is spreading exponentially. What does this mean? You may have seen a version of the infographic on my right that explains the potential impact of social distancing. It nicely illustrates that reducing the total number of disease-spreading contacts each infected person can have a dramatic effect on the total number of infections a short time later. The numbers rely on the mathematical concept of exponential growth. So join me in exploring the world of exponential functions. But before that, I have two questions. First, how A, B, and C are similar? Very good. A, B, and C are involved expressions with a variable in the exponent. We call that an exponential expression. An exponential expression is an expression of the form A times B raised to x minus C plus D, where B is greater than 0 and B is not equal to 1. Second question, how A, B, and C are different? Nice answer! A and C involve only one variable, but B expresses a relationship between two variables. Do you have another observation? Perfect! A and B involve an equality, but C involves an inequality. A, B, and C are examples of exponential function, exponential equation, and exponential inequality. How they differ to each other?
First, exponential function is a function of the form f of x is equal to b raised to x, where b is greater than 0 and b is not equal to 1. Example, f of x is equal to 1.5 raised to x is written in the form of f of x is equal to b raised to x. Aside from f of x, we can also use y to represent function, because f of x is also equivalent to y according to our definition of a function from our previous lesson. These are examples of exponential functions. Moreover, we also have an exponential equation, which is an equation involving exponential expressions. Here are the examples of exponential equations. While an exponential inequality is an equality involving exponential expressions. Inequality symbols used are greater than, less than, greater than or equal to, and less than or equal to. Here are examples of exponential inequalities.
Since you already know how to identify whether the given is an exponential function, exponential equation, and exponential inequality. And now, let's move on with some real-life situations using exponential functions, and that is our second lesson. The three most common applications of exponential functions are exponential growth, exponential decay, and compound interest.
First, let's have an exponential growth. Example, at t is equal to 0, there were initially 40 bacteria. Suppose that the bacteria double every 200 hours. Give an exponential model for the bacteria as a function of t. Let's have the table of values for the number of bacteria and observe the pattern. Now, what have you observed? Very good! Since its doubling the constant is 2, then the exponential model for this situation is y is equal to 40 times 2 raised to t over 200. Exponential growth, if a quantity y doubles every t units of time and y sub 0 is the initial amount, then the quantity y after t units of time is given by this.
Same in our example, we can relate our current situation during this pandemic time. Nowadays, we experience a constant increase in COVID-positive cases in our country. So, please stay at home and follow the safety protocols, and hopefully, it will help to decrease the number of COVID-positive cases.
The second real-life application is exponential decay. Example, suppose that the half-life of a certain radioactive substance is 10 days and there are 20 grams initially. Determine the amount of substance remaining after 40 days and give the exponential model for the amount of the remaining substance. Let's have a table of values for the substance remaining and observe the pattern. So, what have you observed? Very good. The idea is the mass is halved every 10 days based on the definition of half-life in the problem. Since it is halving, the constant is 1/2. Then, the exponential model for this situation is y is equal to 20 times 1/2 raised to t over 10. Exponential decay, if the half-life of a substance in t units and y sub 0 is the amount of the substance corresponding to t is equal to 0, then the amount of y of substance remaining after t units of time is given by y is equal to y sub 0 times 1/2 raised to t over t. And lastly, compound interest is an interest that is computed on the principal and also on the accumulated past interest. If a principal P is invested at an annual rate of R compounded annually, then the amount after t years is given by A is equal to P times 1 plus R raised to t. Example, Mrs. Garcia invested 150,000 pesos in a company that offers a 5% interest compounded annually. Give an exponential model for this situation. How much will this investment be worth at the end of each year for the next 5 years? Let's have a table of values for the amount of money invested. Just substitute the values from the given formula and compute for the amount of investing. Hence, exponential model for this situation is y is equal to 150,000 times 1.05 raised to t. The investment is worth of 191,442 pesos and 24 centavos. This time, our last lesson is about solving exponential equations and inequalities. In solving exponential equations, the equating exponent property is used. Equating exponents property states that in an exponential equation, if the bases are equal, the exponents must also be equal. Or, if the exponents are equal, the bases must also be equal. Here are the steps in solving exponential equations. Step 1. Rewrite the equation so that the bases are the same number. Step 2. Once the bases are equal, you can set the exponents equal to each other by equating exponents property and solve. Step 3. Check your solution. Example, solve 7 raised to x plus 1 is equal to 49. 49 can be written as 7 squared. So, 7 raised to x plus 1 is equal to 7 squared. Now, let us use equating exponents property. 7 raised to x plus 1 is equal to 7 squared. We have x plus 1 is equal to 2. Subtract 1 from both sides. X is equal to 2 minus 1. And x is equal to 1. Now, let us check if 1 is the solution in our exponential equation. Substitute 1 for x. So we have 7 raised to 1 plus 1 is equal to 49. 7 squared is equal to 49. Both sides are equal. In solving exponential inequalities, If both sides of an inequality are multiplied by or divided by the same negative real number, the inequality symbols or sign must be changed. Property of inequality of exponential function. Let b is greater than 1. Then b raised to x is greater than b raised to y. If and only if x is greater than y. And b raised to x is less than b raised to y. If and only if x is less than y. Example, solve 3 raised to x is less than 81. Step 1. Rewrite the equation so that the bases are the same number. 81 can be written as 3 raised to 4. So we have 3 raised to x is less than 3 raised to 4. Step 2. Apply the property of inequality for exponential functions and solve. 3 raised to x is less than 3 raised to 4. So we have x is less than 4. The solution set to the inequality is x is all real numbers such that x is less than 4. Step 3. Check your solution. You may choose any value of x that is less than 4. Let x is equal to 2. Since this satisfies that inequality, x is less than 4. 3 squared is less than 81. Then 9 is less than 81. And that is true. Hence, the solution is correct because it satisfies the inequality.
And that wraps up our episode. This is Benedicto de Juliales saying that in mathematics, every problem has a solution.